Separate and solve the ODE if possible. So in this one we have y prime equals xy. That does look separable, but first let's change the y prime into dy dx for that notational convenience. So that equals x times y. So as usual, we're going to multiply by dx to get the dx out of the dy dx. And we're going to, in this case, we're also going to divide by y. All right, so multiply each side by dx, divide each side by y. So if we do that, we end up with dy over y equals x dx. And perfect, that's separated. I have all the y stuff on one side of the equation. I have all the x stuff on the other side of the equation. So now we have to apply indefinite integrals to both sides. So integral, I'll write this as 1 over y dy equals indefinite integral x dx. All right, so this side is natural log, and to be careful, it's natural log absolute value of y. And I'm going to put the constant integration on the x side. So integral of x is x squared over 2 plus a constant. All right, so next up I want to try and solve for y. So I'm going to exponentiate both sides. So I have e to the natural log absolute value of y equals e to the x squared over 2 plus c. And I do want to simplify this a little bit, so we're going to go ahead and go back up here. So e to the natural log absolute value of y equals e to the natural log e to the x squared plus 2. Oh, come on. E to the x squared plus 2 times e to the c. The reason I want to do that is I want to get that c as just another constant. So right, I have e, which is about 2.7, to a constant. A number to a constant is still a constant. That's really e to the x squared over 2 times c. And I'll just write that as c e to the x squared over 2. All right, and then I can simplify down here. So, sticking around all the time, e to the natural log of absolute value y, well, that's really just absolute value of y. Right, and I still have my absolute value of y down here. Now, I'd really like to get rid of the absolute value of y, and it turns out I can. So whatever ends up happening, this is a little hand wavy, this either ends up being plus, positive y or minus y. If y is positive, then it's going to be positive y. If y was negative, the absolute value will negate the negative y to make it positive. And that's going to be, c e to the x squared over 2. But the thing is, this constant can also absorb this plus minus. So kind of a really big abuse of notation if I do, plus minus times plus minus y equals plus minus c e to the x squared over 2. Right, quite hand wavy, but intuitively, positive times positive will be positive, negative times negative is positive, so we end up with just y. And that plus minus can actually be absorbed into the c. So we're just going to call it c, right? A positive times a constant or a negative constant, that's still a constant, so I'm just going to call it c. So the whole solution ends up being c e to the x squared over 2. And that's the solution. And so going back here, we should have been able to solve this as well with integrating factor, which you learned already or later on. But right, there's usually more than one way to solve a first order difference equation, and we'll get the same answer each time, and this happens to be the solution.